enjoy this. All right, now this week, this is part two. And what I'm going to look at this week is talking about a rule of thumb that they used to use. We actually have this in our design book, and we also show this in our motor, generator, transformer, compressor book. In the generator transformer, motor, compressor book, we go a lot more in depth on a lot of different things because it's strictly dealing with all the things for your motors. But this is what you would look at, and they would tell you here that a non-time delay fuse will hold 5 times, 500%. What's that say? I don't have it
Oh, I was
checked.
just gonna check the amperage.
Okay.
Right on.
But it says a non-time delay fuse will hold 5 times, 500% its rating for approximately a quarter to 2 seconds based on the type used. And this gives you an example here. If I take a 150 amp non-time delay fuse, take it at 500%, that's going to give you 750 amps. Okay, now I want to show you something here. Now, that's just a basic thing that we tie in, and I want to show you here things that you get into. Now, this next one, I'm gonna give an example to tie all this in. We're gonna have an illustration, and we're gonna talk about a 460 volt, 50 horsepower, three phase uh, motor. And when you look at this motor, you're gonna see that it tells you in table 430.251b, it's going to tell you that the locked rotor current here is 363 amps. Okay. Now watch this. All this that we're showing you is just to prove what they used to do back in the day. And when they started looking at designing these tables and everything, this is how they knew that they had a proper size overcurrent device there in order to provide protection for the inrush current of that motor. Now,
Okay, gotcha.
look at this. All right. Now, what I'm going to do is I'm going to determine here if 80 amp fuses will hold the motor's locked rotor current in amps. And this is a design B, 50 horsepower, 460 volt, three phase motor. And as we just looked at that table in 430.251, 251B, it said the 50 horsepower was good for what? 363 amps. Now look
Yeah.
at this. We tell you a non-time delay fuse will hold about 5 times, 500%. So if I take those 80 amp fuses at 5 times, looky there, the holding power of that fuse is 400 amps, which will hold the
Nice.
locked rotor current of that motor at 363 amps.
Sweet.
Now,
Wow.
I can tell you, I've seen a lot of publications out there. I don't see anybody teaching this type of stuff. And
Sure.
sometimes when you're on the job, just knowing stuff like this, if you don't have a code book with you to know exactly what it is, if you know these rule of thumbs, you could actually apply this and have enough there to make sure you're taking care of that locked rotor current.
Yeah, and one thing I noticed too about when we're in some of these industrial projects, you're not gonna be like a real fine line on some of this stuff, especially when you have like that 5 times rule.
Mm-hmm.
I mean, you look at like the difference between like a 70 amp fuse and an 80 amp fuse. I
Mm-hmm.
mean, if you're looking at that, you're gonna have some problems if you go with that 70 amp.
Sure. And and that's what all this is for, is to give you an idea of how you go about looking and sizing these, and how did they make these assumptions over time. There
True.
was a lot of testing and everything that was done, but before they had these tables, there was a way they went about doing this, and this is how they did it. And
Dude, I'm guessing there was a bunch of 1,000 foot long runs that were smoked up back in the day.
probably so. All right. Now look at this. It tells you a time delay fuse. It'll hold 5 times for a rating of 10 seconds. So if I take 150 amps at 500%, that's going to give me 750 amps. I'm just doing the same thing. I'm not really changing anything here. So if you look here, same calculation. I came up with 80 amp fuses. What do they hold? 400 amps, a 50 horsepower, 460 volt, three phase motor. The locked rotor current was 363 amps. It takes care of it. Now,
Nice.
Watch this. Now we're going to look at instantaneous trip circuit breakers. All right. Now I'm gonna read the second sentence here. It says thermal protection is not provided for instantaneous trip circuit breakers. Instantaneous trip circuit breakers, now pay attention to everything I'm telling you here, will hold about 3 times their rating on the low setting and 5 times their next setting, 7 times their next setting, and approximately 10 times their rating on the high setting. Okay.
Okay.
And these certain types, they can be adjusted from what? 0 to 1,700%. And you can pick that up over in 430.52C3 that tells you about that 1,100% up to 1,700% for the
So
minimum, for the
is
maximum.
this is this like a motor overload device?
Yes. And
Okay.
and watch this. You're going to love this. Now watch. I'll come right back to this. What we're going to do here is I'm going to do an instantaneous trip circuit breaker, and we're going to ask you, will it hold the locked rotor current motor using a medium setting? So we're going to do a medium setting. You can go 5 or the next one, which is 7, all the way up to 10. We're just going to do the 5% here. And it's going to
Right.
be a design B energy efficient. It's a 100 horsepower, 460-volt three phase motor, and it has a 150 amp frame. Okay. Now, if I come back and I look at this right here, and I pick up 100 horsepower here, come across for that Design B 460-volt three phase motor, it's going to tell you the inrush current here set at 725 amps, right?
Yeah.
Okay. Now, watch this. On the medium setting, it says here I could take that. Let me go back just so everybody can see this one more time. Right here, it says on the low setting and 5 times their rating on the next setting. We're going to call that could be 5 or 7 times, but we're just going to check the 5 times because we're doing it on a 150 amp frame here. All right.
True.
Now, watch this. I take 150 amps times 5 gives me 750 amps on the medium setting, which is going to be enough to hold that locked rotor current of 725 amps.
Hey, so is there anything that factors in here on like the TCC curve, or is this automatically adjusted for with that piece of equipment?
That I can't answer. Alls I know, this is something that they used to use as a rule of thumb when they were making these assumptions, and
Okay.
based on that rule of thumb, I don't think it had anything to do with that. It was just something that they
Okay.
did out in uh, the industry when they were looking at sizing.
Who looks like Juan is lighting you up. Our non-time delay fuse is the same as acting fuses.
Well, that depends. I mean, it's uh, if you go back and look, let me go back because it depends which type of non-time delay fuse you're putting in. Because if you look back here, one of the things that we tell you right off the bat, it's rating for approximately what, a quarter to 2 seconds. So if it's operating at a quarter second, yeah, that's a fast acting fuse. Okay. Same with your different type of overcurrent protection devices, could be a circuit breaker or something like that. It depends on what type of fuse you buy, but yeah, that could be a fast acting fuse. You got that right. But if you go back and look here, since you're asking that question, say I look at a time delay fuse and you pick this up, it says a rating for 10 seconds. The time delay fuse is not going to be a fast acting. You see the difference? And that's why we put this information in here so you know the different type of fuses and what's their rating time for. Because based on that rating time is going to decide if it's a fast acting fuse or not. And when you get back over and you look at a time delay fuse, it's from a quarter to 2 seconds. Okay.
Right. And when you're talking 10 seconds, that is that's an eternity when it
Bet your
comes
ass
to
it
an
is.
arc event. That's 60 cycles.
Sure it is. And I'll say this, if you go look at other publications, they're not going to tell you this type of information. And
True.
the reason we put this in here and we show you all this stuff because we want you to understand exactly what it is you're looking for here to understand how the different type of overcurrent devices react. and and how do they make assumptions to make sure they can take care of that locked rotor current? And then we tell you what the clearing time are that's set up for those different type of overcurrent devices. And if you ever look at, like, if you go to our 70E book, when we go in and we're talking about fast acting fuses, you'll notice we always use non time delay fuses. Why is that? Because they clear a quarter second to 2 seconds. And that's one of the type that you would use in order for it to clear quickly. And that helps takes reduce that arc flash that you would have exposure to.
Yeah, absolutely. And I'm not really technically agreeing with you, Juan, on using the fuses as an inrush overcurrent protection device, or and it just to use a control transformer. Not really sure what you mean by that, but it it just depends on what you're trying to do. If you're using this math that they have in here, you have to have those fuses set a certain way, or you're just gonna pop the fuse every time. So it depends on what you're doing. I mean, if you're trying to, protect, say, the equipment from damage, then you're gonna want to have that dialed in because you don't want to have an unintentional rapid disassembly in the field.
Sure. And this is a good example. If I'm looking at an inverse time circuit breaker, how are they designed? They're designed with the instantaneous trip features to do what? They detect short circuits and thermal characteristics to do what? To sense slow heat buildup in the circuit. So
True.
if the heat should occur in the windings of the motor, the instantaneous values of current will be detected by what? The thermal action of that circuit breaker. Okay.
True.
And then that, based on that and the current, it'll trip open if that, of course, is sized properly. Okay.
True.
So that's why all of this is set up that way. And when you get in and you start looking at these inverse time circuit breakers, they'll hold about 3 times the rating, and and they hold them for different periods of time. But the reason that is, it's all based on the frame size. And that's what I
True.
was saying in the last illustration. I was talking about the frame size being 150 amps for that instantaneous trip circuit breaker. The frame size is going to determine what that holding amps is going to be, and then you've got your different values that you use to see if it'll hold that locked rotor current of that motor.
Yeah,
And let
and
me let me one more thing. Let me say this
sorry.
also. It's very important that it does. Let's say, for example, I'm in Article 695 and I'm dealing with fire pumps, or I'm dealing with magnetic circuits, anything like that, and you go look at 240.4A. Basically, what it's telling you there, when you're dealing with those overcurrent protection devices have to be able to hold the inrush current of that motor and that locked rotor current indefinitely. Okay.
True.
And the reason it does, because they'd rather the motor burn up than the trip, because if it trips, then all of a sudden you lose the power and everything over there for your fire pumps. And then if somebody, say, God forbid, somebody's standing outside and they got a big magnet come down, pick up a car, and the breaker trips, and you're happen to be walking by underneath it and it drops. You see what I'm saying? I mean,
Yeah.
there's certain reasons that they used to go in and do these based on percentages. This is a good example of that.
Yeah, and I was before. I didn't mean to interrupt you, but basically, I was just to Juan's point. Basically, it depends on what you're doing. You can't just make a blanket statement. I almost feel that fuses are a more accurate way to dial what you're doing if you're doing your math right and doing all your calculations correctly.
Sure. And here's a good example. This is a while ago we did an instantaneous trip circuit breaker with a 150 amp frame. I'm doing the exact same thing here, but I'm doing it with a 250 amp frame. Same size motor and everything. So if I go back here and I look at my 100 horsepower, it's still 725 amps for the locked rotor current. And then if I come over here and look, I said you're going to take a circuit breaker usually at what? 3 times. So if I
Yeah.
take a 250 amp frame at 3 times, that's going to give me 750 amps. If that was a 150 amp frame, then this inverse time circuit breaker, that wouldn't have been large enough.
True. I like
Okay.
it.
And, but when you look at this is how they used to go back when dad was going through this. People were like, they didn't understand what he was saying, about how they would take the percentages, and this is how they made the determinations for the inrush current and all of that for that locked rotor current for the motors. And this is how they look at it right here. And that's how they go about applying those percentages.
Nice. And yeah, Juan, I do know that Busman does have an app just for all the people out there. Just go to your either your Google store or your Apple Play Store, and you can just look up Busman app for a calculator, and you'll basically be able to type in like what amperage you're at, what conditions you're at, and stuff like that, and it can give you a really handy reference. So good comment. Thanks for the comment,
Yeah,
for sure.
sure. And but when you look at that, they have those tools now, but back in the day, they didn't have those tools available to them. So they had to make some assumptions. Well, all the assumptions and everything were based on these percentages. And if you look at the percentages, the frame sizes, and everything, you'll see that they were large enough to take care of that locked rotor current of the motors based on those percentages. That's what Dad was talking about.
Dude, I love it, dude. That's a really good rule of thumb, man. That is freaking awesome.
Yeah,
That's really good.
I
That's
always
handy.
tell everybody when I'm doing this stuff, I've been in a lot of classes, and I'll pull that up. And I remember one time I was doing a class, I had this older individual in there. He was about, I think at the time I was like 40 years old or something like that, and he was like 65, and he raised his head and he goes, "That's exactly how we used to do that." He goes, "We didn't have all these tables and stuff." And he goes, "We did it on a percentage based on exactly how you're showing it right there." he goes, he goes, "I appreciate you showing us that." He goes, "A lot of these young guys in here doesn't understand how the NEC has matriculated over the years." He goes, "It was based on some of these rule of thumbs that you're talking about."
Nice. Yeah, that's good. Well, freaking Pops is still teaching us, so that's freaking awesome. A big shout out. The only problem is that with your new background, it's gonna really suck when he turns the lights off on you. So
Yeah, well,
it'll get
he,
darker.
he's out of town this week. He's on a
Oh,
big attorney case. Um,
okay.
there something about some equipment or something. I sent him some documentation in an email yesterday, and he's up in Atlanta right now. They started up north somewhere, but they're going to 4 locations looking at the equipment, and he's basically making sure everything's designed right. And apparently, they're having to go back and change a bunch of things. So,
Oh, okay.
but
All right.
they
Well,
hired him because he's an expert.
well, that's really awesome. Great topic of the week. I like it.